Good day everyone, welcome back to the continuation of our discussion on the topic forces. Today we will be treating the resultant of several concurrent forces. Now for resultant of several concurrent forces, here we resolve each force into vertical component Fy and horizontal component Fs. It is done with the aid of a table as shown in the example that follows, and after doing that our resultant will be equal to the square root of summation all the f of y square plus the summation f of s square, where arrow is the resultant and summation f of y is the sum of all the f of y and summation f of s is the sum of f of s. Now sometimes we will be asked to look for the angle that our resultant makes with the horizontal or with the vertical. Now in order to do this, we will now have to sketch a new diagram with the sum of our fs being our s direction and the sum of our fy our y direction, taking note of the negative sign. So if there is negative, our direction will be in the negative s direction, and if there is a negative in our y, to be in the negative y direction. When this is done, to get our theta, tan theta will be equals to the summation f of y divided by the summation f of s, and theta will be equals to arctan summation f of y divided by summation f of s, where theta is the angle which the horizontal makes with the horizontal. Now we have this question from NECO 2004. It states that find the sum of the components of forces along the s axis. Now we are looking for all the forces along the s axis. Now for our diagram, we are given the direction of the force and their angles. Now remember that when we do this, we only use the angle with respect to the horizontal. So for our 10 Newton force, the angle with respect to the horizontal will be 90 degrees. For our 20 Newton force, the angle with respect to the horizontal will be 60 degrees, because 90 minus 30 will make the angle to the horizontal 60. And for our 30 Newton force, the angle to the horizontal is also 30. Now we are going to be tabulating our forces and their angle. So we have our force, the angle, and the horizontal component. For our first force, the 30 Newton, the angle is 30, and the horizontal component will be 30 cos 30, which is equals to 30 times root 3 over 2, which is cos 30, which will be equals to 15 root 3, which will be equals to 25.98. And for our 20 Newton force with an angle of 60 to the horizontal, it becomes 20 cos 60, which is equals to 20 times 1 over 2, which is equals to 10 Newton. And for our 10 Newton force with the angle of 90 to the horizontal, it becomes 10 cos 90, which is equals to 0. Now adding all our forces, it will sum up to 35.98 Newton, which is our final answer, C. We have another question from NECO 2004. It states that two forces P and Q act at a point. The magnitude of P is 24 Newton and the magnitude of Q is 86 Newton. If P acts in the direction of north 40 degree east and Q acts in the direction of north 30 degree west, find 1. The components of P and Q, 2. Magnitude of the resultant force, 3. Angle with the resultant forces makes with the horizontal. Now from our knowledge of bearing, we try and sketch out our forces, and when we do that we get the diagram as shown on the screen. Now mind you, we are taking our angle with respect to the horizontal, so if the angle is with respect to the vertical, we are subtracting it from 90 and getting our corresponding angle. Now after doing this, so tabulating our value for our force, which is the 24 Newton, the angle to the horizontal is 50 degree, and our vertical component will be 24 sin 50, which is equal to 18.39, and our horizontal component will be 24 cos 50, which is equals to 15.43. And for our 86 Newton force with the angle of 60 to the horizontal, our vertical component will be 86 sin 60, which is equal to 74.48, and our horizontal component will be minus 86 cos 60, which is equals to minus 43, because it's in the negative s direction. Now taking our total, our vertical total will be 18.39 plus 74.48, which sum up to 92.81, and our horizontal component total will be 15.43 minus 43, which sum up to be minus 27.57. Now our resultant will be equals to, from our formula, the summation of all our vertical component square plus the summation of all our horizontal component square, and we'll find the square root of that, which makes r to be equals to the square root of 92.87 in bracket square plus in bracket minus 27.57 square. And finding our squares, it will be equals to the square root of 8624.8369 plus 760.1049, which sum up to be equals to the square root of 9384.9418. And when we find our square root, to be equals to 96.88 Newton. For the third part of our question, that is the angle which the resultant force makes with the horizontal, we are going to be sketching our new forces, and doing so, our horizontal component will be in the negative x direction because our force is negative, and our vertical component will be in the positive y direction because our force is positive. Doing so, we get the diagram as shown on the screen. Now from our formula, to get theta, which is the angle the resultant makes with the horizontal, tan theta will be equals to summation f of y divided by summation f of s. So therefore tan theta will be equals to 92.87 divided by 27.53, and theta will be equals to arc tan 3.3685, which is equals to 73.47. So the angle the resultant makes with the horizontal is 73.47 degree. We have another question from NECO that states that given that F1 6 Newton and 0 degree is, and F2 8 Newton and 90 degree are two forces acting at a point, what is the modulus of their resultant? That is, we are asked to look for the resultant. Now first of all, we are going to be sketching our curve and our forces, and when we do that, we get the diagram as shown on the screen. Now remembering we are using our angle with respect to the resultant. Now tabulating our forces, we have our force F1 with a magnitude of 6 Newton, and the angle to the horizontal is 60 degree. So the vertical component will be 6 sin 60, which is equals to 3 root 3, and the horizontal component will be 6 cos 60, which is equals to 3. And for our second force F2, the magnitude is 8 Newton, and the angle to the horizontal will be 0 degree because it's on the horizontal, so it does not make an angle with the horizontal. And the vertical component will become 8 sin 0, which is 0, and the horizontal component will be 8 cos 0, which is equals to 8. Now summing up and getting our total, our vertical component, the total will be 3 root 3, which is equals to 5.20, and our horizontal component will be 11, that's 3 plus 8. Now for our result will be equals to the square root of 5.20 in bracket square plus 11 square, which will be equals to the square root of 448.04. And finding our square root, it will be equals to 12.167 Newton, or approximately 12.17 Newton. And the correct option is B. We have another example from November that states that 3 coplanar forces, 4 root 3 Newton, 5 root 3 Newton, and 7 Newton act on a particle in the bearing 060 degree, 180 degree, and 270 degree respectively. Find the magnitude of their resultant. Now we are going to apply our knowledge of 3-digit compass bearing and sketch our forces, and when we do that, we get the diagram as shown on the screen. Now we are going to tabulate our forces and find the resultant vertical component. Now for our first force, 4 root 3, the angle it makes with the horizontal is 30 degree, so the vertical component will be 4 root 3 sin 30, which is equals to 2 root 3, and the horizontal component will be 4 root 3 cos 30, which is equals to 6. Now for our second force, 5 root 3, the angle it makes with the horizontal is 90 degree, and our vertical component becomes minus 5 root 3 sin 90 because it is facing the negative y direction, that's negative y axis, which will be equals to minus 5 root 3, and the horizontal component will also be minus 5 root 3 cos 90, similar reason, which will be equals to 0. Now for our last force, the 7 Newton, our angle to the horizontal is 0 degree, that is, it's on the horizontal component, so the angle to the horizontal is 0. Our vertical component will be 7 sin 0, which is equals to 0, and our horizontal component will be minus 7 cos 0 because it's in the negative s direction, which will be equals to minus 7. Summing everything up, our total becomes, for our vertical component to be minus 3 root 3 newton, which is equals to minus 5.20 newton, and for our horizontal component to be equals to minus 1 newton. Now for our resultant will be equal to the square of the vertical component plus the square of the horizontal component, and we'll find the square root of the answer, which makes r to be equal to the square root of, in brackets, minus 5.20 square plus minus 1 in brackets square, which will be equal to the square root of 27 plus 1, adding together to be equal to the square root of 28, and simplifying to be equal to 2 root 7, and our correct answer is C. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can easily get the hard copy in bookshop, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.